This is a class of two-dimensional geometry, and we solve a problem from pair of straight line. And the problem is prove that the equation AB minus h square into ax square plus 2hxy plus by square plus 2gx plus 2fy plus a square plus b square minus 2+2gh, this is equal to 0, represent a pair of straight line. So we have to show first the given equation is a pair of straight line. Okay, and these lines forms a rhombus with the straight line given by ax square plus 2hxy plus by square equal to 0 if this condition hold. Okay, now we starting from to show this equation forms a pair of straight line. We know that the general equation of second degree, that is ax square plus 2hxy plus by square plus 2gx plus 2fy plus c, this is equal to 0, is represent a pair of straight line if there required two conditions. The first condition is AB minus h square greater than 0. Okay, this is the first condition. This condition gives the pair of intersecting line. Okay, this is intersecting line. And the second condition, this represents the pair of straight line which is given by ABC plus 2FGH minus AF square minus BG square minus CH square, this is equal to 0. These two relations together represent a pair of intersecting straight line. Now from the given first relation, if we write this relation as of the form this, so we get this is as ax square plus 2hxy plus by square plus 2gx plus 2fy plus this is af square plus bg square minus 2fgh by this is ab minus h square. This is equal to 0 and this is named as 1. Okay, here we let AB minus h square greater than 0 because otherwise it not represent the pair of intersecting line. Now comparing this line with the given line, we can write that A this is equal to A, H this is equal to H, B this is equal to B, G this is equal to G, F this is equal to F. Only changes in C, C this is equal to AF square plus BG square minus 2FGH by AB minus H square. Right? Now, if we put the value of C, because C is other than this C, here we put the value of C here or left hand side of this relation, we can write this relation as AB minus h square into C. We take common C from this and this, and we put this value of C here. This is AF square plus BG square minus 2FGH by AB minus h square, and write other term unchanged plus 2FGH minus F square minus BG square. And it is clear that this cancel out and we get the result 0. Okay, so if we take or if we consider or assume the first condition AB minus h square greater than 0, then we get automatically condition 2 satisfied. Hence we say that the given equation 1 represent a pair of straight line. Hence we write here, hence 1 represent a pair of intersecting lines. Straight line. Right? We first prove the pair of straight line. Now we have to show that this pair of straight line forms a rhombus with the straight line ax square plus 2hxy plus by square equal to 0. Now we name ax square plus 2hxy plus by square. This is equal to 0. This is relation number 2. Since in relation number 1, this is the second degree term in x and y, and in relation number 2, this is also the second degree term in x and y. And we show from this second degree term, because second degree term are same in two lines, so we say that 1 and 2 represent two parallel pair of straight line. Right? Two pair of straight line which are parallel to each other. And this straight line obviously passes through 0, 0. But this straight line, this is not passes through 0, 0. Let it be passes through alpha, beta. Okay? We draw a rough sketch here for this line and this line. Let this is x-axis and this is y-axis. And let ax square plus 2hxy plus by square are represented by these two lines. This is OA and this is OB, and we complete two parallel lines drawn here, and we complete the parallelogram. Let it be M. This is alpha beta. This is the point of intersection of 1. These two represent together. This is line 2, and these two represent together. This is line 1. Okay, and obviously this is a parallelogram because this is parallel to this and this parallel to this. Now our first aim to find out the point of intersection M of two lines given by 1. How to find the point of intersection? We know that if we write the determinant AHG, HBF, GFC, here C is given by this term. Okay, we write this as C, and we know that this to first row gives the point of intersection M, and we write this is A alpha plus H beta plus G, this is equal to 0, and H alpha plus B beta plus F, this is equal to 0. And solving these two lines, we get the point of intersection alpha beta, and which is given by alpha by beta by 1 by, and this is HF minus BG, and this is HG minus AF, and this is AB minus H square. So we write alpha, this is equal to HF minus BG by AB minus H square, and beta, this is equal to HG minus AF by AB minus H square. We get the point of intersection. Okay, and we draw two diagonals of the parallelogram. Okay, two diagonals of the parallelogram. Now if we see here, these two diagonal bisect each other perpendicularly. Okay, and we have to only show these are bisected perpendicularly, and we know that since this is a parallelogram, the diagonals are automatically bisected, but we have to show only perpendicular of these two lines. Okay, now we have to find the slope of AB and slope of OM, and already we find out the slope of OM. What is the slope of OM? Slope of OM this is given by beta by alpha. Okay, because this is 0 0 and this is alpha beta, so the slope of the line is beta by alpha, and given by, we putting the value of beta and alpha, we get hg minus af by hf minus bg. We directly cancel out ab minus h square from both terms. Right, now we have to find the slope of ab. We first find the equation of AB. How to find the equation of AB? It is easy to find the equation of AB from the line 1 and from the line 2. How to find? If we subtract 2 from 1, okay, by 1 minus 2, we get. What we get from 1 minus 2? This is given by this term and this term cancel out, and we get the relation as 2gx plus 2fy plus, this is, we write af square plus bg square plus, sorry, this is minus 2fgh by ab minus h square, this is equal to 0. We name this straight line as relation number 3. Now this equation represent the straight line AB. Okay, because it is clear that this straight line passes through both the line 1 and 2, because we get line 3 from calculating 1 and 2. Okay, and this is not passes through origin, because here constant term is present, so this is not OM, and it is obvious that this is the another diagonal, this is AB. Okay, so this represent diagonal AB. Now it is easy to find the slope of this diagonal, that is the slope of AB, which is given by minus g by f. Okay, if we arrange this term or this straight line as y equal to mx plus c, so the slope of AB, this is equal to minus g by f. Right, now we use the condition of perpendicular of two diagonal and getting the result as minus g by f into, this is hg minus af by hf minus bg, this is equal to minus 1, right, and cancel out minus minus and getting the result h into g square minus a fg, this is equal to h into f square minus b fg, and we get h into g square minus f square, this is a f minus bg, sorry, this is a minus b into fg, we take common here. Okay, and obviously this is nothing but this condition, and we write this as a minus b into fg plus h into, this is f square minus g square, this is equal to 0, and this is our required result we want to prove here. Right, this is very important and interesting problem of pair of straight line. Thank you for watching.